Welcome. In this screencast, I want to do 3 examples of power series, and I want to use the ratio test each time to determine the interval of convergence, because sometimes the series that we look at are geometric, and that's great, but they aren't always geometric, and that's a problem. So let's find the interval of convergence for the sum as n goes from 0 to infinity. Notice again that's a 0 of x to the n over 2 to the n plus 1. And to be clear, if n equals 0, this is 1 over 1 plus 1. And if n is 1, this is x over 2 plus 1. And if n is 2, this is n squared over 4 plus 1, and so on. So it's like a polynomial, but it doesn't ever stop. Okay? So to find the interval of convergence, we find rho. Row, row, row your boat gently down the stream. Its the limit as n approaches infinity of the absolute value of the n plus 1 term over the nth term. The n plus 1th term looks like this. The nth term looks like that. And so we wonder to ourselves, what is happening here? Well, the x to the n and the x to the n plus 1, they leave behind an x. These, we think about the limit at infinity. At infinity, the ones don't really matter. These end up leaving a 2 in the denominator. In the limit, they leave a 2 in the denominator. So rho is the absolute value of x over 2. So what's the interval of convergence? It's the set of x values for which x over 2 is less than 1. Where is x over 2 less than 1? Well, that happens between -2 and +2. So this is the scenario that we talked about here. There's going to be a finite interval centered at the center of some radius. So the center is 0. These are all x minus 0, x minus 0. The center is 0, and the radius of convergence is 2. But we also know that we have to check the endpoints. What happens at the endpoints? Well, if x is 2, what is our series? If x is 2, this is the sum of 2 to the n over 2 to the n plus 1. Does that converge? Well, the plus 1 doesn't really matter. These terms are basically 1. We're adding 1 and 1 and 1 and 1 and 1 infinitely many times. This diverges. If x is -2, then we have a sum of -2 to the n over 2 to the n plus 1. This is an alternating series. You could write out the first few terms. This is an alternating series, but the terms are getting bigger, and they're not getting closer and closer to 0. So this diverges by the alternating series test. And so the interval of convergence is just -2 to 2 open on both sides. Will that always happen? No. Find the interval of convergence for the sum as n goes from 1 to infinity of -1 to the n over 4 to the n times n, all multiplied by x minus 5 to the n. Okay, so what do we got? We figure out what rho is. Row, row, row your boat gently down the stream. Its the limit as n approaches infinity, the absolute value of the n plus 1 term over the nth term. Please stop, sir. So what happens? The 4 to the n and the 4 to the n plus 1 leave a little something behind. The x minus 5 to the n and the x minus 5 to the n plus 1 leave a little something behind. This is not a problem because we're taking absolute values, so we don't care. And n factorial, n plus 1 factorial leave. It's not an n factorial. You silly. It's not an n factorial at all. So n over n plus 1, that goes to 1 as n gets large. So when n gets bigger and bigger, everything drops out, and you're left with the absolute value of x minus 5 over 4. When is the absolute value of x minus 5 over 4 less than 1? Well, that happens when 1 is less than x, which is less than 9. So this is the scenario where we have an interval centered at the center. Center is 5, centered at the center. The radius of convergence is 4, the distance from 5 to 9, the distance from 5 to 1, that's 4. So now we've got to consider the endpoints. If x is 1, then this is negative 4 to the n times negative 1 to the n is 4 to the n over 4 to the n times n. That's the harmonic series. It diverges. If x equals 9, then we have 4 to the n over 4 to the n. That drops. And we have the harmonic series, but it alternates. The alternating harmonic series converges, so the interval of convergence is from 1 to 9, including 9. Including 9. I'll do one more. I know that I am close to the unofficial border of 10 minutes. What about x to the 2n over 2n factorial? This is if x is 0, this is 1. If x is 1, this is x squared over 2 factorial. If n is 2, this is x to the 4th over 4 factorial, and so on. What is the interval of convergence for this power series? Well, we figure out what rho is. Row, row, row your boat gently down the stream. It's the limit as n approaches infinity of the absolute value of the n plus 1th term. Notice we plugged in n plus 1 for n and multiplied by 2 over the nth term. Algebra tells us that these cancel, leaving behind an x squared. Algebra tells us that these cancel, leaving behind a 2n plus 2 and a 2n plus 1. And we think about what happens as n goes to infinity. Well, as n goes to infinity, the only n's are down here. And if the only n's are down here, then regardless of what x is, these win out. Goes to 0. And 0 is less than 1 for all x. There is no x value that makes 0 bigger than 1. And so the interval of convergence, this series converges for all x because rho is always less than 1. Couple of quick OYOs for you. A couple of quick OYOs for you, things you might want to consider knowing how to do. Find the interval of convergence for x to the n over n factorial, for negative 1 to the n times x minus 3 to the n over the square root of n squared plus 1, and for x to the n times n factorial. Take a moment. Hit the pause button, see if you can figure them. So in the first case, rho turns out to be 0, and that's always less than 1. In the second case, we get an interval centered at 3, because that's an x minus 3, so the interval has to be centered at 3. 4 is in, 2 is out. And then in the third case, we get a rho that's infinity, and infinity is always bigger than 1. Okay, hope that's helpful. See you soon.